I'm Dr. Legena Henry, PhD. I am the CEO and founder of Rum and Sargassum Incorporated, but I'm also the renewable energy lecturer here at UW Cave Hill. Sure. So I came to Cave Hill in 2019. I was teaching a class called Sustainable Energy Systems. And there was one day we were talking about the transition because Barbados is on a path to being 100% fossil fuel free by 2030, which is an ambitious goal and the biggest goal among all the CARICOM countries. So it's always a topic of discussion in this class called Sustainable Energy Systems. There was one day we were talking specifically about transport, and a student said, "Okay, Dr. Henry, I can't afford an EV, and there's no way I could buy an EV anytime between now and 2030, so what's going to happen to me?" And I said, "Oh yeah, you're right, me either." So what are we going to do? What are the regular folk going to do when we have this energy transition? So that summer, I took four of the more promising students from that class and sat with them in this lab. The IDB funded small stipends for them, and we sat down brainstorming what is the less expensive transport solution when the country transitions, because the electric cars are great. They have all their benefits. E-mobility is a big part of the renewable energy transition, but what about the rest of us? And so we set out looking first at sugarcane. So we went around Barbados looking at cane. We went to Sugarcane Breeders Association. We drove through the island, going to different rum distilleries who use sugarcane molasses to produce rum, and started to try to understand sugarcane as a transport solution for Barbados. Looking at Brazil. Brazil is this great example where 2/3 of road traffic drives on sugarcane. But 2 weeks into that exercise, it was a 10-week experience, and 2 weeks in we realized, okay, sugarcane is not the answer. The cane industry in Barbados is actually on a slight decline and has been for 7 decades, just kind of declining. Based on numbers we calculated, we realized only 6% of road traffic could be driven by sugarcane if you took all the cane in Barbados and just put it towards traffic. 6%. And we need the cane for other reasons, not just driving. So that was out. At the same time, one of my students, her name is Brittany McKenzie, she was riding home on a van, and she drove past mounds of sargassum, and people were there with the equipment getting it off the beach, and she's like, why don't we just look at sargassum? So she's driving home. She comes to me the next day in the lab, and she comes and she says, "Why don't we think about sargassum?" And I was like, oh shucks. We spent the last 2 weeks talking about sugarcane, but you know what? You're so happy and you're so full of enthusiasm right now. Go ahead. Go and run some experiments on sargassum, because if you're going to be this enthusiastic for the rest of these 10 weeks, then go ahead and do it. And so we've been around to the rum distilleries, we've been to various places, and so we thought, let's just bring together some of the different substrates. And she went to Dr. Nikolai Holder, who is a biochemist at Cave Hill, a microbial biochemist. And he was able to guide her in terms of setting up these microdigester experiments. At the same time, I had the rest of the team looking at things like, okay, if we produce biomethane, what is the pathway from biomethane to road traffic? I had another part of the team looking at carbon emissions, and then another part of the team looking at the resilience of that solution. And so, yeah, we spent the next few weeks, the sargassum results came back really good. Compared to some of the grasses that the same Dr. Holder had published the year before that about the methane out of grass, it was super comparable. I mean, it was maybe half as much by normal milliliters of methane per gram of fresh matter in. So we're like, it's not even like out there, it's not even a solution that's mildly comparable. It looks good. And so we completed those experiments. So that summer, our intention was to publish work. When the IDB saw the results of our work, because remember, they were funding the student stipends, they thought, this is more than we had expected. Can we do a technical paper based on this, and we worked with them over the next year and a half, going back and forth with drafts of the paper, recalculations, etc., to refine it, and published in April 2021 a paper on biomethane results from sargassum seaweed and rum distillery wastewater. So yeah, it was one summer, one great question from an undergraduate student in a class that led us to the sargassum solution. 2019. So we had gone around to the rum distilleries and collected distillery wastewater from the 4 largest rum distilleries in Barbados that summer. We got sargassum. We went into the ocean and got some fresh sargassum and ran the experiments. How do you go from a waste product to fuel? Well, the thing that does all the work is microbes. There's something called anaerobic bacteria that can actually digest the biological matter and produce methane gas. That's the thing that gives us energy. The fuel is methane gas. Other things, there are other gases as well. There's carbon dioxide, there's other trace gases, there's H2O. And so the biogas that's produced has to be upgraded. And with sargassum is around, well, with our formula, we get around 60% methane. And so you take out the other things to get that methane that your cars could drive on. So the fact is, the microbes do all the work on biological matter, converting it into byproducts and the useful methane gas. Anaerobic digestion is in the absence of oxygen, so the whole system is airtight. So this is not something where you'll be next to the biogas station and smelling rotten sargassum, because everything is airtight. So it's like you're not even going to have a clue about it. And this solution it works all over Europe. They're using waste to produce energy. And so it doesn't sound very romantic at first to say, let's rot some sargassum to make fuel from it. But the fact is, it's a very clean form of energy, and it takes waste products. And what would happen with the waste products without this is that the methane would just release into the atmosphere anyway. But we're saying take the methane and put it to work. And so you get less methane into the atmosphere. You actually do reduce global warming. You reduce atmospheric warming. And so it's a win-win-win kind of solution. None of the technology we're proposing is new actual things. It's not new working parts. All these working parts worked for a long time before that. So we're saying this is a new fuel that we're putting in old technology to get fossil fuel free transport. And so it'll take some investment to get to the point of customers buying from us. Ideally for us, the first customer will buy from one of our dispensers in January 2026. But until then, we're setting up this demonstration gas station, which we'll use to gather data to continue to understand the solution. But we're very sure that it works. So that's it. 2026, I'll call you and say, come down and fill up. But between now and then, we hope by this summer to demonstrate to you and the rest of the public in Barbados and throughout the region that, hey, we're driving this car using sargassum seaweed. So we have a few social media platforms that we put out progress, and weekly we kind of report through Twitter, Instagram, LinkedIn, Facebook, YouTube, but we also have a webpage, rumandsargassum.com, where people could go and learn more about this solution.